my name is Semih Aktepe and I am going to present you my project, which is simple weather forecast algorithm by using Viterbi's algorithm. Before explaining my code, let's talk about Viterbi's algorithm itself. The Viterbi's algorithm is a dynamic programming algorithm for finding the most likely sequence of hidden states called the Viterbi path. That results in a sequence of observed events. It is particularly useful in the context of hidden Markov models, HMMs, which is a powerful tool for modeling sequential data. In an HMM, the hidden states are not directly observable and the observed events are dependent on the hidden states. The goal is to find the most likely sequence of hidden states given the observed events. The Viterbi's algorithm is an efficient method for solving this problem by finding the most likely path through the state space of the HMM. The Viterbi's algorithm was first proposed by Andrew Viterbi in 1978 as a decoding algorithm for conventional codes, which are widely used in telecommunications. Viterbi realized that the algorithm could be applied to HMMs, which we have similar mathematical structure to conventional codes. Since then, the algorithm has been extended and applied many in fields, such as speech recognition, bioinformatics, and pathfinding by predicting new paths based on past decisions. So, our algorithm will be about that. After learning the history of Viterbi, let's talk about the principle of our code. What does this code do? The code uses Viterbi algorithm to determine the most likely sequence of weather conditions, sunny, rainy, cloudy, given a fixed sequence of 5 observations. The algorithm starts by initializing the Viterbi and path matrix. The Viterbi matrix stores the maximum probabilities of being in a certain state at a certain time, while the path matrix stores the most likely previous state that led to current state. Then, the Viterbi algorithm function is called, which iterates over the observations, updating the Viterbi and path matrix at each step. For each time step, t, the algorithm considers all possible states j and looks back at the previous time step t minus 1 to find the states I that maximize the probability of being in state j at time t, given the observations up to time to t. This probability is calculated as the product of the maximum probability of being in state I at the time t minus 1, the transition probability from states I to states j, and the emission probability of observing the current observation given that the current state is j. Once the Viterbi matrix is fully populated, the algorithm traces back the path matrix to find the most likely sequence of the states. The main function finds the final states with the highest probability and traces back the path to determine the most likely sequence of weather conditions for given the observations, and it prints itself. But what is the main purpose of our code? As I mentioned before, the main purpose of the code is to determine the most likely sequence of weather conditions, sunny, rainy, cloudy, given a fixed sequence of 5 observations. The code draws a new paths by looking at the past observation. Therefore, we are able to guess a new weather condition by looking at the past. While beginning the video, I said it's a simple algorithm, but for being sure of that and determine that fact, we should find the time complexity of our code. The Viterbi's algorithm has a time complexity of O t times n square, where t is the number of observations and n is the number of states. Moreover, our complexity will be O 5 times 3 square, which is equal to O 45. But what if we decide to make some operations such as adding or removing an element or else finding one? The Viterbi's algorithm is primarily a dynamic programming algorithm, which means it solves the problem by breaking it down into smaller subproblems and catching the solutions to these subproblems in order to avoid redundant calculations. Adding or removing observation would affect the time and space complexity of the algorithm. Increasing the number of observations would increase the time complexity by a factor of t, and the space complexity of by a factor of t time n, so adding new observation would make the algorithm run slower and use more memory. Removing an observation would decrease the time-space complexity by a factor of t. So, removing observation would make the algorithm run faster and use less memory. Searching for a specific sequence of states given a sequence of observation is the main function of the Viterbi's algorithm. It is done by running the algorithm with the specific observation. This doesn't change the time complexity of the algorithm. In general, adding, removing, or searching do not change the asymptotic time complexity of the Viterbi's algorithm, which is O t times n square. However, they can affect the actual running time and the memory usage of the algorithm in specific cases. At the ending of the video, I would like to say thank you for listening.